Hello friends, welcome to my channel. Let's have a look at problem 26. Remove duplicates from sorted array. In this video, we're going to share a treatment or solution based on reassignment. First, I'll read through the problem statement to digest the requirement, and then we share the algorithm and then the coding. First, let's look at the problem statement. So given an integer array called nums sorted in non-decreasing order, we are required to remove the duplicates in place such that each unique element appears only once. The relative order of the element should be kept the same. So this is a problem requirement. So we are required to return the key after placing the final result in the first key slots of nums, where key is the number of unique elements in the nums array. So here, do not allocate extra space for another array. We must do this by modifying the input array in place with O1 extra memory. So this is the requirement. So here is how we test the code based on here. So actually we just need to test if the first key slots contains the unique elements in the right order. So here is one example, two examples. So for example, in this case, so we're going to have two unique values, that is 1, 2. So the first position should be 1, and then in the second position we place 2. So actually we can ignore all the other positions. So in this explanation, we used underscore because these are not evaluated or tested. So similarly, you can interpret example 2. So here the unique numbers are 0 up to 4, so in total 5. So we need to return 5, and the first 5 positions should be occupied by 0, 1, 2, 3, 4. So all the others we do not care, right? So that's the problem statement. Let's also look at the constraints. First, the length of this list is not empty because its length is bounded below by 1, and the length is bounded above by 3 times 10 to the power 4. And secondly, the elements in the list are bounded in between negative 100 and positive 100, and the nums is sorted in non-decreasing order. So with that said, so we are ready to do the treatment or analysis. So here let me share this one. So the idea actually is very simple. So first we assume that there are key unique numbers in the array. So by the problem requirement, we just need to make sure the first key positions correspond to the unique numbers in order. We do not need to care about the tail elements. So here is a note. We do not need to know key a priori at all. We use this key here just to fix the idea or algorithm. So now let's look at the algorithm. So for this algorithm, first I'm going to initialize a list length, or you can just say index, as ls equals 1. So the reason is that so the first element should always be num0, right? Here you can interpret this ls means the index set for unique elements we meet. So later we want to also interpret ls by length, so just the difference by 1 from the index. So this is step 0. Step 1 is for each of the I from 1, 2 up to n minus 1, where n is the length of nums. So we check if nums I equals or not to its previous one, nums I minus 1. So if this condition is true, right, it means that we so if in other words they do not equal, it means that we meet a new unique number. So we're going to set nums, the slot is list, the current index, then to be the nums I, and then we increment this list by 1 because we set one more unique number. And finally, we just need to return ls or ls plus 1, depends on how you implement this algorithm. So here is the remark. the above algorithm set all the unique elements in position without paying attention to the tail positions, right? So here is a walkthrough. For example, this is nums and this corresponding indices. So for example, when I equals 1, so we have ls equals 1, so nums 1 equals nums 0 equals 0, so we just need to continue. And then when we look at meet the 1 in index 2, so we know that this does not equals to 0, so we're going to set current slots at list. In other words, nums ls, so ls is 1, right, in this position, so we're going to set it to be the 1 here. So then we increment this ls to 2, then we continue this procedure. So actually this is the detailed walkthrough. So if afterwards, after this for loop, we check the reassignment, actually we can see the nums result list results or rest at 0, 1, 2, 3, 4, but all the remaining 5 positions we do not alter or change that. So we only care about this 5 positions. So the largest index set is 4, so we need to return 5 because 5 is the length or the number of unique elements. So with that said, actually we can share the shortcode. We just need to translate the algorithm into code format, right? So this is actually very straightforward. First, we are going to introduce the length. This is the n, just for convenience. And then I'm going to set this to be 1. So you can start with 0 or something else, but that's still okay. So if I set this to be 1, so I'm going to start from index 1. So for I in range 1 to n, right? So what we are going to do is to check if nums I does not equals nums I minus 1, which means that we meet a new unique element. Then we're going to set nums ls equals nums I, right? So this is the logic. Then we increment this ls by 1. So notice that the variable ls is always less than or equal to I, right? Because of possible duplicates. If the array does not contain any duplicates, so we always have list equals I, right? So afterwards, so we just need to return the list state because of the way we write, right? Because once we set, we increment this ls by 1. In other words, with the increment by 1 after the last step, so this ls actually is the index, so it's a value larger than the index we most recently set. In other words, it can be interpreted as the previous unique elements. So with that said, I guess that's the code for this problem. So we can do a test. So it passes the first example. So now let's actually print out this nums after we do the reset. So nums. You can see here we have 2 unique elements, 1 and 2. So after we do the algorithm, so we have 1, 2 set in the right position, but the third element we do not care. So with that said, let's comment out this print statement and then do a check for all the cases. Yeah, it passes all the cases. Yeah, I guess that's about it for this problem. So this problem is an easy one marked by Leetcode. However, it's very interesting. So with that said, I guess that's about it for this video. Thank you.